The second derivative test. So we will investigate another way to find the maximum and minimum values of a function. So the second derivative test says this: let f be a function and f prime of c equals 0. Okay, it has to be that f prime of c equals 0. If f prime of c is not 0, you cannot use the second derivative test. You go back to the first derivative test. And the second derivative of f exists on an open interval containing c. So you cannot have a corner on the first derivative graph. So there are some qualifying conditions here. So if those conditions are met, if f double prime of c is greater than 0, so if the second derivative is positive, then f of c is a relative minimum. Now I want to pause here because I did grade your quizzes, and I feel that maybe I failed somehow because quite a few of you did the exact same thing. Does this say that the relative minimum is c comma f of c? Does it say the relative minimum is a point? No, it does not. The relative minimum, what does f of c represent? The y value, okay? So the relative minimum is a y value, and then we identify where it's located, but the relative minimum or relative maximum are not points. They are the y values. So I wanted to point that out. Then if the second derivative is positive, and again, I'm trying to go real slowly here so we can process. If the second derivative is positive, what do I know about the graph of f? We learned this, not yesterday, but the day before. It's concave up, right? So think about this. If the second derivative is positive, it's concave up. So doesn't that make sense that there's a relative minimum there? For some reason, like when I try to avoid the second derivative test. I do, because I like the first derivative test. And what's going to happen, though, is on the AP exam, they're going to force it. And I'll show you why in example 2. They're going to get you so that you have to know it. But it's rare that they don't even really come out and say use the second derivative test on the AP exam, but they word problems in such a way that you have to use it. So if in number 2, if the second derivative is negative, that means it's concave down, f of c is a relative maximum. So in example 1, it says find the relative extrema for f of x equals negative 3x to the 5th plus 5x cubed using the second derivative test. So I'm going to pause, and I want you to find the first derivative. Now be careful here. In order to use the second derivative test, this c value is where f prime of c is 0. Not when it's undefined, but where it's 0. So it's like finding the critical point. So you have to do that. Find the first derivative, find where f prime of c is 0, then go find the second derivative and test the sign, positive or negative, of f double prime of c. I'm going to give you a short head start on me. I do have office hours at the end of the day today, so if you're having any difficulty with any of your content, this is the last office hours before exams. Again, Friday, Monday, Tuesday, you'll have 3 class periods to get some one-on-one help from me and ask people at your tables. Then we will have the big Unit 4-5 test during our second period exam slot. I'm going to go ahead and get started. I'm going to find the first derivative, which is negative 15x to the fourth plus 15x squared. I do need to find where the first derivative is 0. So those are my, in fact, C values, okay? So those are the values for C. Now I'm going to go find the second derivative. So I bring down the powers, decrease by 1. And so here's what you're going to do. You're going to go find f double prime. Do you see f double prime of these 3 values? When I get f double prime of 0, the second derivative test does not apply. It doesn't mean that there's not a relative extrema. It doesn't apply when the second derivative equals 0. Then let's go find f double prime of 1 and f double prime of negative 1. So when I do f double prime of 1, I got negative 30. So based on the second derivative test, what do I know about x is 1? Good job, okay? I know, to me, it's like seems counterintuitive. I'm like, it's negative, it should be a minimum, and it's positive, you know? So here's what I have. I have that x equals 1 is where f of x has a relative maximum. So let's go find it. So f of 1 so 2 is a relative max at x equals 1. Because f double prime of 1 is less than 0. Well, I probably should say and f prime of 1 is 0. Like those conditions have to be met. Now I'm going to go do f double prime of negative 1. Let's go figure out that one. So that'll be negative 60 times negative 1 cubed plus 30 times negative 1. So that's 30. So x equals negative 1. F of x has a relative minimum. So let's go figure that one out. So that's what, -2. So I would say -2 is a relative minimum at x equals -1 because f double prime of -1 is greater than 0 and f prime of -1 is 0. Now, I do still need to figure out what's happening at x is 0. Something is potentially happening there because my critical numbers are x equals 0 and x is plus or minus 1. So I took care of x is 1 and x is -1. But what's our other tool in our math tool belts that help us figure this out if we can't use the second derivative test? The first derivative test, okay? And the first derivative test says this. Let's make sure we're keeping all of this straight. I'm going to make a number line with the first derivative. So, and this is why it's critically important that you label number lines, because now we have the second derivative that tells us where the function is concave up, concave down, and points of inflection. The first derivative tells us where the function is increasing, decreasing, and relative extrema. So I did the sign chart already and had minus, plus, plus, minus. Now, I want to make sure that I'm not misleading you here. Do you see f of 0 is neither a relative minimum or relative maximum because f prime of 0, wait, let me rewrite that, because at x equals 0, f prime of x does not change signs. Now that's not true in general, okay? This is not a generalization. Just because the second derivative test failed does not mean that it's not a relative extrema. Just in this case, it happened to not be. And so if you take a look to the graph at the right, do you see there that that's not a hill or a valley? It is constantly increasing there. And that makes sense on our sign chart. It's not changing there. It's constantly increasing. All right, so let's go ahead and when you're ready, let's look at example 2. And I want to pause a moment and give you 3 or 4 minutes to look at it, think about it before I work it out. It says, given the values below for x, f of x and f prime of x, and actually I have f double prime down there too, along with the fact that f prime of x has only 2 zeros on the interval, the open interval from -3 to 10, and f double prime of x has only 2 zeros on that open interval, -3 to 10. So think about what we know, and here's where they get you, okay? This is where they're going to get you. That you don't have an equation, so you can't get away with just doing a sign chart for the first derivative test. All right, so try as many of these as you can. I'm going to give you a few minutes. All right, let's go ahead and start with letter A. A says identify all x values where f has a relative minimum. Justify using the first derivative test. So for those of you that sort of knew what you needed to do, can somebody give us your solution, how you figured it out? Julia, what'd you do?
So I went and I looked where f prime of x equals 0.
Okay, so when did that happen?
At -1 and 3.
Okay, good job. Then what'd you do?
And then I looked at the x double prime values of -1 and 3.
Okay, so do you see it says use the first derivative test? Okay, that's going to help us in part B. That's great thinking, and I bet you got the right answer. But let's try to follow it. Yeah, Eric, what'd you do? Okay, so I'm going to kind of pull it out from here to maybe help those of you that are like, what? What are you doing? So watch this. We're going to go look at the f prime of x. This is the first derivative test. And to the left, and so like, do you see here's my -1 and here's my 3, okay? So I'm kind of branching it here. So then to the left of -1, so I'm going right here, this is positive. In between, that's a negative, and to the right, it's positive. So then, Eric, what did you figure out then to do the relative minimum? Yeah, because why? You got it. Okay. F has a relative minimum at x equals 3. It didn't ask me, it says just identify all the x values. Because f prime of x changes signs from negative to positive at x is 3. All right, so then, Julia, I think you probably did part B beautifully then there, because this is the second derivative test. So I still need to know, I already know this information, right? Okay, f prime of x is 0 when x is -1 and x is 3, so I have that, yeah. Oh, I suppose I could include that as a critical number, but do you see on the left and the right it's positive, so it's not a relative extreme of a great, yeah, absolutely. I could include that on my number line. Absolutely, thank you. And let me go back and I'll do that. So then, but it's not where f prime of x is 0 for the second derivative test. So then what I'm going to do here is I'm going to go check the signs of f of negative, f double prime of -1, and f double prime of 3. So I go to my table. F double prime of -1 is -1, which is less than 0. So f has a relative max at x is -1 because f double prime of -1 is negative and f prime of -1 is 0. Yeah, Daly? Oh, not at all. Nope, you can say f of x.
Oh, I said no, please.
No, and see, and they're saying we're f, so I just was following the notation, was all.
Okay.
Now, f double prime of 3 is 2, so that produces a relative minimum, but they didn't ask me that. Okay, So now, letter C. Identify all x values where f has a point of inflection and justify. So let's play the what do I know game. Yeah, Logan?
You know the chemical points of -1 and x equals -1 and x equals 3. Is that right?
Okay, so we do know that x equals -1 and x equals 3 are my critical points. Okay, so then what do I know about points of inflection? Walter?
They are aware of the second derivative sign changes from either positive to negative or negative to positive.
Yes, okay, so points of inflection occur where f double prime of x changes signs. So I'm going to look at my table and now I'm looking at just the second derivative and at what values does the second derivative change signs? At x is 1, okay? So I would say, and if you want, I'll say f of x has a point of inflection at x is 1 because f double prime of x changes signs from negative to positive at x equals 1, and f double prime of 1 is 0, like that. You have to have that's where it's a potential point of inflection. It doesn't occur at x is 7 because it doesn't change signs in the second derivative. So you do need this piece right here, okay? That piece is important. All right, part D. What is the equation of the tangent to the curve y equals f of x at x equals 5? What are the two pieces of information we need in order to write an equation of a line? Yeah, Maxton? Okay, so we need a point and a slope. So if I have the point 5, where do I find the y-coordinate? From the table. So what is the y-coordinate? 3. All right, then my slope is going to be f prime at 5. So using your table, what is f prime of 5? 2. Now I have my pieces of information. Y minus 3 equals 2 times the quantity x minus 5. You are welcome to leave it like that. However, I'm going to go ahead and simplify it just because we should practice that if on a multiple choice question, they're putting it in y equals mx plus b form. All right, that wraps up the 5.7. So we have, about 15 minutes for you to work on your homework.